Hey, today we're going to show you how you can go from something like this to making your own custom ornament like this. The first thing you want to do is decide what kind of characteristics you want your project to have. In this project, we're going to copy the idea where a button press will change the characteristics of the LED that flashes. The first button press is going to blink fast, the second button press is going to blink slow, the third button press is going to blink all, and the fourth button press is going to turn all off. Now that we have the general idea of what we want it to do, we'll go ahead and start breadboarding. And we want our breadboard to look something like this. Our LEDs, a push button, and an AT Tiny 13. The first thing we're going to want to do is try to make our LED turn on. So we're going to write a simple program just to have it do that. Once we know that we're able to program the chip and have it do what we want it to do, then we're going to go ahead and scale up the complexity from there to make it do the really awesome animations that we want. Okay, so we're going to go ahead and start a brand new project right here. And let's just go ahead and open one up. We're going to just call it LED Flasher. And after that, let's go ahead and change our chip to be an AT Tiny 13. That's what we're working with here. And everything else looks pretty good. Let's go ahead and hit next. Save it. Alright, so now let's go ahead and get into our main program. Once we're here in our main program, we're just going to go ahead and type ddrb or equals 1 bit shifted 1, and that's going to go ahead and allow us to set that specific pin as an output. The next thing we'll do is we're going to go ahead and turn that pin on by typing port B or equals 1 bit shifted 1, and if it works, we should see, there we go, an LED turning on. Pretty simple, but that allows us to make sure that our chip's working. We're going to go ahead and erase all that we just did, and we're going to go ahead and set a volatile variable, call it state, and we're going to initiate it as a 0. We're going to go ahead and set our ddrb or equals 1 bit shifted to 1 or 1 bit shifted to 2. That's going to allow us to set those both as outputs. And port B or equals 1 bit shifted 0. That's going to set that specific pin as a pull up. It's going to pull that pin high. We're going to go inside our main loop here, and we're going to write the code that's going to restrict our state variable to the values between 0 and 3. And now we're going to go ahead and write a switch statement that's going to cycle through the button presses. And depending on which button state we're in, it's going to vary the LED sequencing that's going on. For the first button press here, we're going to go ahead and alternate each pin that the LED is turning on. So first we're going to go ahead and turn on one pin. and then we're gonna go ahead and turn it off, and then we're gonna turn on the other pin. We'll once again turn it off, and it's gonna keep on repeating that loop while it's in that button state. The second button press is going to do pretty much the same thing as the first button press, so we'll just copy and paste all that code that we just wrote. The one thing we will change though is the value from 10 to 50 because we want the delay to be a little bit longer. Finally, we're going to go ahead and type our code for our last state. And in this state, when the button's pressed for the third time, it's going to turn all the LEDs on and leave them all on for the duration. Here we're going to go ahead and see how it works. Button pressed once, all LEDs flashing fast. Button pressed again, flashing slow. Third time, they all stay on. And fourth, they all turn off. At this point, we've got everything worked out, and now the only thing left to do is to transfer it to a PCB. You can do this using protoboard, or you can do the method I did, and you can actually create the PCB in Eagle, and then have it sent out to a professional board shop like I did.